Okay, so what you had done previously on that short little, whatever you want to call it, exercise or SLO exercise, okay, is you actually described a chemical reaction. You just don't realize that's what you did, okay? And we will be spending a fair amount of time on this, okay, because we want you to be successful upon the conclusion of this course. Now, that work ethic that we ask you to put into this, okay, and you can say, we're not ever going to use this again. That might be possible. But the work that it takes to complete this is what we are trying to teach you is a good work ethic, whether you think you're going to be using this or not. Okay? Does that make sense?
Yeah.
All right. And we will do one more, and then we're going to do some exercises. Okay? Together, not on your own, like you did with what was on the board before. Okay. So anytime you're looking at a substance on the left side, okay, those are your reactants. In other words, if someone tells you something that you don't like and they decide to slap you in the shoulder, you had reacted to that. Okay? So when one substance interacts with another, that's what that means by a reactant. So because it's in a reaction. Okay, so I want to do this, and then this is where we'll stop talking for that. Okay. All right. So then on the right side in this chemical reaction, that is what's being produced. You have the reactants on the left side of the arrow, the products on the right side. Okay? And you classify these into 5 different types of reactions. Okay? And the first one's a synthesis. Okay. Well, when you say photosynthesis, you're not wrong. You're using light to make something. That's why it's called photosynthesis. Okay. So where does that process take place then? When you said photosynthesis?
In the leaf.
Okay. So in plants. Yeah. I agree. Okay. Decomposition is another type of reaction. Then you have single replacement, double replacement, and then combustion is the last one. So when you balance these reactions, you're doing what's called a conservation of mass. You are conserving by illustrating everything on the left-hand side of the reaction balances with everything on the right-hand side. Because what happens is and I think it's a good application or way to explain this. For those of you who take general chemistry in 2 years, okay, you do not. Okay, we talk about what's called limiting reactants. Okay, so where does that tell you that is in the chemical equation? No, not in the middle. Okay. So where is the reactants, or where are the reactants in a reaction?
Left side.
On the left side. Okay? So when we talk about limiting reactants, think about 6 people on the volleyball court, 5 people on the basketball court. Okay?
How many on the football field? 18. 9 or 11?
We'll just say 9. But regardless,
11 teams.
if you were watching someone who's in foul trouble, let's say they've got 4 fouls late in the game. So if that takes place, then they're probably limited on what they can do on defense. Would you agree? Because what happens if they get 1 more foul? They're out. So you are limited on what you can do. Okay? There is a specific problem we talk about where back when the Apollo missions were taking place, there are 3 reactants that have to be in the right proportions. Because if they are not, you're not going to get the proper amount of horsepower that you need for that rocket. Okay? And I don't think you'd want to be the engineer that miscalculated that and left them behind. Okay? Or did not work or blow up. Or, okay? 1986 in January, the Challenger.
Was she the first teacher?
As far as I know, yes. Okay, you farmers know what this means. In hydraulics, okay, if you are leaking hydraulic fluid in the line, chances are there's a little washer that's shaped like this. It's a something ring.
O-ring.
It's an O-ring. So if you have to replace that O-ring, maybe it's just worn out or it's cut or something to that effect, you're leaking hydraulic fluid, and you can tell because if you leave your equipment with the, what do I want to say, your scoop or bucket up here, and then 2 hours later it's down on the ground, what does that tell you? You've got a hydraulic leak. Okay? So what had happened in this Challenger accident, if you want to call it that, the liquid oxygen that burns with that shuttle, it was leaking. So that liquid oxygen eventually got back to the thrusters, ignited, and the whole thing blew up. It's rather unfortunate, but that was probably something that happened maybe a year before. I mean, the engineering that went into that probably occurred a year before that shuttle took off. It's, again, just unfortunate that that had happened. That's not the only time we've had, I wouldn't say problems, but accidents in with space shuttles either going up or coming back down. Back in 2003, a little more recent than 1986, of course. Does anyone ever heard of the Columbia Space Shuttle? So what was significant about the Columbia? Well, it worked just fine.
They couldn't get back down.
They got back down, but unfortunately the heat shield was damaged before they took off. So upon re-entry, how do we want to... This is one way you can look at it. If you're standing in the water, okay, if you move your hand like this underneath water, does that give you a nice smooth profile? Water just moves right over the top, right? Okay, but what happens if you turn it this way? It's a lot harder because there's more friction. Well, what happens is when that heat shield was damaged, it's creating little vortices of heat, and eventually it just got too hot from the friction and exploded upon re-entry. Very unfortunate. Okay. So let's go ahead and look at some examples of this. Got a little ahead of myself there. Okay, now we're taking a lot of prior knowledge that you were just evaluated over yesterday. Okay? Even though these are not compounds, this is. Okay? So with that being said, as we move forward then, what is the symbol for calcium? Okay? And what is the symbol for chlorine? All right? So we've got calcium.
Chloride. If it's iodide. This is chlorine. This is chloride. Can you not read? One of them says
What is calcium chloride? Ca what? Is that right? Okay. Why do you have to have a 2 there? You're right. So the charges add up to 0. How many of you believe that that equation is written correctly now? In general chemistry terms. Okay, if you do this, if that's where you stop, anything you do 5 steps down the way is going to be wrong. So if this was a problem in stoichiometry, anything you do beyond this is wrong, because that is wrong. No. And maybe we just haven't spent enough time on it, but I do remember writing things like this down. And I think we're missing this one. Something significant about them when they're by themselves.
double bond.
No. Say that again. These are diatomic. If you forget that, it doesn't matter what you do, anything beyond this, it's going to be 100% wrong. Okay? So when we look at halogens or gases, when they're by themselves, what do you got to do? Well, this is a halogen, right? What does it say here? You have to have a little 2 there. Okay? Now you can go ahead and balance it, which we really don't need to now because it is balanced. Sometimes when you get these reactions, sometimes they are just balanced. Those blue lines that you saw, there's 1s in front of there now. So what happens is we didn't change anything, so it is balanced with 1, 1, and 1. Okay? So if we had this, okay, there's 1s in front of each one of these compounds. Okay? So, how many chlorines are on the left side?
2.
How many chlorines are over here?
1.
So, by trial and error, what would you put in front of that KCl?
2.
A large number 2 called a coefficient. That gets distributed through the entire compound. So now your chlorides are balanced, but how many potassiums do we have?
1.
How many potassiums do we have? 2. Okay? How many potassiums are over here?
1.
How many do we need? You'd have 2. Okay? Now everything's balanced. So what you would write, 1, 2, 1, 2. All right, we're running short on time. That's what we're doing so far. Okay? And we will continue balancing equations tomorrow. Catch up to you next time.